students, we have started differential equations in different notions like limits, continuity and now differentiability. Differentiability, you should know all the formulas of differentials, the derivatives of x, that is all the formulae as I told you for the previous problem. So, the same way we continue for here, and this sum actually you should know the basic formula of derivatives. What are the basic derivative formula? What are the basic formula in derivatives of sin x, cos x, tan x, likewise e power x, a power x, log x, all that you should know. Without knowing, if you do sums, it is a waste. If a student is doing a multiplication table application problem without knowing table, how it is much difficult. In the same way, without knowing this formula, if you do this sum, it is a waste. Likewise, so but you should know the complete formula. Okay, now let us, I assume that you know the formula. Now I continue. Let us start. So here the problem is in exercise 10.2 problem number 11. What is it? Find the derivative of the given function y. That is nothing but find dy by dx. What is it? Find dy by dx. Some function may be involved with theta or t. That is the reason why with respect to x or theta here. So, but this function involved with x. So, the domain is x. So, we are calculating with respect to x, dy by dx. Here, in what way we can resolve this problem? There are two methods we can solve. One is u by v, direct, and another one you can simplify, since this is a trigonometric problem. So, you can go with some trigonometrical approach and make it simple, then differentiate. There are two methods you can resolve this problem. One is direct method like u by v, and another one as that is nothing but what is it? Is making this one tan x is sin x by cos x and minus 1 and 1 by cos x. I have not done the differentials. I am doing some trigonometrical simple methods, then we will see how to derive. So, now this one we are taking LCM here, cos x. So, sin x minus cos x and 1 by cos x, remember that cos x getting cancelled, sin x minus cos x. So, y is equal to sin x minus cos x. So, such a big one we made it as a simple one as sin x minus cos x. Now, you can differentiate this problem. In what else? So, dy by dx. dy by dx, sin x differentiation, as you know, it is cos x, and cos x differentiation is what? Negative of sin x, remember that. Sin x is cos x and cos x is negative sin x. So, that means it is nothing but cos x plus sin x. So, this problem we have solved this way, but if you do not know this process of eliminating trigonometrical process, direct method is what we can do a little. This sum we can solve in the other way, like u by v process, that is y is equal to tan x minus 1 by what else? Secant x. This is u, this is v. U by v process. The same sum I am doing by u by v. Here, very simple method, that is trigonometry method. So, just changing the term, and finally, we have found the function as sin x minus cos x, and differentiation we got the result, simple. Even sometimes you may not know how to go with the trigonometrical approach. Direct formula if you want to apply, you can do. This way also you can get the answer, you will arrive the same answer. Let us see. U by V, you know the formula. What is U by V? D of U and V as the function, U by V here and V square, V into du by dx minus U dV by dx. This is the process. You know the formula, anyhow just I recall this formula for your reference. Here this is U and this is V. What is U? Tan x minus 1. What is V here? Secant x. What is dV by dx? That is secant x differentiation is secant x tan x. Tan x differentiation is what? Secant square x. That is du by dx is secant square x, and one differentiation is 0. So now let us recap. Well, let us go back to the formula side. Dy by dx V square secant x the whole square, and then V secant x du by dx. Remember that du by dx is this secant square x minus, and u is what? Tan x minus 1. Then next part dV by dx. dV by dx is secant x tan x. So this is V square V du by dx minus u dV by dx. So now let us take secant cube x. Here is just multiplication. Secant x into tan square x plus minus into minus plus secant x tan x whole divided by secant square secant x the whole square. Let it be here. Let me see. So we have this function, this one. You can divide everywhere by secant x, first part, because everywhere there is secant we can take common and then simplify. What is this part here? Secant x means here secant square x. Here if I take one secant x, this will become tan square x, and here it is tan x whole divided by secant x the whole square, and these two getting cancelled, and remaining term secant square x minus tan square x is 1. That is also identity of trigonometry. So 1 plus tan square is secant square x minus 1 is tan square x. So here remember that 1 plus tan square x is secant square x. So secant square x minus tan square x is 1. What you can write here, this part. So here on the whole I just cancel it, on the whole, remember that. So that secant x I have taken common on the whole, secant x here, that means secant square x, and minus tan square x, 1 secant x I have taken common in this. So secant square x minus tan square is 1, 1 plus tan x by secant x, remember that. 1 plus tan x by secant x. Then if you want to simplify, you can simplify. If you not required, even if you want to do 1 by secant x, this part, this is tan x by secant x. 1 by secant x is what is it? Nothing but cos x here, and here sin x by cos x, here 1 by cos x. So both are getting cancelled here, cos x plus sin x. Remember that in both way we can do. This is a direct process, direct method, without knowing anything. Directly you can do so by way of u by v, taking v square v du by dx minus u dv by dx, and then differentiating and then substituting the values and taking secant x as common on the whole, and finally we have arrived like this, and then 1 plus tan x by secant x. After that we split the term as 1 by secant and tan by secant. Finally we arrive like this. This is the method. First we are doing trigonometrical approach, then finally we derived. In this way this problem is solved.